All right, so dealing with radicals that have variables, you kind of follow the same pattern. We want to make sure we have a buddy that can leave the house. So if I look at x to the fourth, what that actually means is x 4 times, right? So we're looking for a buddy that can leave the house. I've got x has a buddy, so one x will be able to leave the house. X has a buddy, so another x can leave the house. So what we're going to actually get is x had a buddy, it could leave the house, times x can leave the house, so it's x squared. If you get an odd exponent, like x to the third, we still have x times x times x, but now we're going to have the fact that there is a variable that can't leave the house, that doesn't have a buddy, because we've got x times x. That x can leave the house, but this x can't, so we're going to write it that way. An x can leave the house because it's got a buddy, and then one x doesn't have a buddy, so it stays in the house. So that's the principle behind it, but do we really want to always draw them out? Not necessarily, because what if we had x to the 11th here? Do we want to write all 11 out? No. What we want to do is take our exponent, 11, divide it by 2, and that'll tell us how many buddies we'll be able to have. And the remainder, what will stay inside of the house. So 11 divided by 2, closest number that's even is 10, so it's like 5, and there's going to be a remainder of 1. What that means is when I write this with a radical, I'm going to have 5 x's that can leave the house and 1 x that didn't have a buddy, that stays in the house. So this is our final answer. So you want to divide by 2 because we want a buddy, so we want pairs, so we divide by 2. Then I can take, let's say, y to the 20th, z to the 7th. So I want to look for buddies. So y to the 20th, I divide by 2, and I get 10. So that means I've got 10 y's that can leave the house, no y's that didn't have a buddy that remain. There's no remainder. So I'm going to give myself a little space and write the final answer here. So 10 y's can leave. And then for z, I've got 7, so I divide by 2. So 7 divided by 2, it's like closest even number is 6. So 6 divided by 2 will leave me with 3. There's a remainder of 1. So that means 3 z's are going to leave the house. 1 is going to remain. The remainder is always going to be remain. That's supposed to be a z. 1 z will remain in the house. So if you have variables, you want to divide the exponent by 2 and figure out if there are remainders or not. So divide by 2, figure out if there are remainders because those are the ones that stay in the house. For some of the ones where you have kind of leftovers, something like that, we take each piece separately. So this 7's already outside. So at the very end, we'll have something being multiplied by 7 on the outside. So I take the numbers first. 12 has to be separated out into 2 numbers that multiply to 12. I would go 6 and 2. 6 can be divisible or divided. We can find those factors. So I'll go 3 and 2. So we need a buddy to leave the house. Only 2 has a buddy. So that 2 is going to leave the house. We're going to have that 7. And then the 2 is going to leave the house. My final answer is going to be down here. I'll do all the work on the side. And then I'll leave a little bit of space because there's probably something that's going to have to stay in the house. What stays in the house? It's the 3 that didn't have a buddy. So the 2 was able to leave the house, the 3 stays in. Then the variables. I've got x to the 6th. The exponent, I divide by 2 to see how many are going to leave the house, how many are going to stay or remain. So I've got 3 with a remainder of 0. There's no remainder. So that means I've got 3 x's that are going to be able to leave the house. Then the y's, I take the exponent divided by 2. So that means 2 y's are going to be able to leave the house. So my final answer, I'm going to multiply 7 into 14, x cubed y squared with a 3. That's the only one that stayed in the house. We'll do one more example like that. Okay, so we're starting off with 4 square root 9x to the 3rd, y to the 7th. Okay, so I like dealing with the numbers first. 9 breaks up into 3 and 3. So 3 has a buddy. It's going to be able to leave the house. So it's going to join the 4 out there. So it's 4 times 3. Leave a little space. Looks like we don't have any numbers inside the radical, but we could have variables. So we leave a little space. Then I look at x to the 3rd. Variables, we divide the exponent by 2. See if we have any remainders. So 3 divided by 2, that's 1, remainder 1. So that means 1x is going to go outside and 1x is going to remain inside. So I'm going to write x to the 1st, x to the 1st. Then y's, I've got y to the 7th. I divide that by 2. So that means 3, remainder 1. Because I always look, maybe I'll do it on the side. So 7 divided by 2. How many 2's fit into 7? 3 2's, because it's 3 times 2 gives me 6. And I'm left, I have a remainder of 1. That's what I'm doing every time. So that means I have 3 y's on the outside, 1 remaining on the inside. So my final answer is going to be 12xy cubed square root of xy.